طيب this is term 3 week 6 physics. كله it's half about the different types of radiations, okay, which are very important. I suggest you to read over it in the book. I won't be going over each one. بس أكيد they're gonna get something from the book that they didn't put in the quiz. I'm telling you from now, so don't be surprised إذا بيطلع لكم سؤال بكرة that you didn't see in the quiz. Okay, and I'm gonna go through the quiz. That's it. But please read over the book. What are some properties of ultraviolet light? Okay, it's obviously harmful to life and can cause skin cancer. It affects photographic films. Okay, films يعني the camera. And ultraviolet light in small amounts is essential for the synthesis of vitamins. Ultraviolet light is the one from the sun. Okay, and you guys know that we need the light from the sun to produce vitamin D. So that's what they mean by the effective synthesis of vitamins. Can it pass through glass? No, it can't. And do they possess less energy than light? No. We call it ultraviolet because it produces more than visible light. Okay. Question 2. Which of the following are achievable to reduce fossil fuel consumption? This is all in the book, by the way. There's no formulas, there's nothing. I just have to explain. Okay, to reduce fossil fuel consumption, obviously fossil fuels are polluting, so we have to reduce the consumption of it. And how do we do it? We can first start by increasing the consumption of natural gas relative to coal, because natural gas, if we burn natural gas, it actually releases way less carbon dioxide than coal. Okay, so that works. Switching to hybrid or FEV cars. FEV is like electrical cars. Okay, obviously that would be better. Insulating power plants. I don't know what this means, but I didn't see it anywhere in the book. I'm not gonna pick that. Substituting all fossil fuels with solar energy. This would be a good idea, but substituting all fossil fuels would be wrong because you should only substitute some of them. Okay, some fossil fuels are still essential. You'll see in the next question. Okay, burning fossil fuels that give out less carbon dioxide per unit energy produced. Obviously, we want that. Okay, question 3. This is what I said. Why do we need to uh, save some fossil fuels and use some? Because we have no right to use up all the energy resources. Obviously, we have to save it for future generations because we have no right to use it all up because they are important sources of plastics and medicines. Okay, they are sources of plastic and medicines. So if you stop using them completely, when هيروح all medicines with plastics, you need them. Okay, the resources of oil and natural gas are limited. Okay, they're limited. Okay, why do you have to save them? Because they're limited. If you use them all up, you're going to use them all up. They're not unlimited, they're limited. So you have to save some for the future generations. Do they not pollute the environment? Of course, that's wrong. They do pollute the environment. Are they the only efficient fuel for production of electricity? Obviously, that's wrong. There's nuclear, there's solar, there's all those types. Question 4. What is one way to solve the problem of carbon dioxide? You can just bury it underground. That's it. It was in the book. Hole, you match them. Okay. All of them, by the way, are in the book as well. This is only one function of each one. In the book, there's more than one function for each one. Microwaves, obviously, for cooking. Infrared radiation is for night vision. Okay, they said that at night you can use infrared. They actually use it in the police. In the police at night, if they're trying to see, like they use telescopes that use infrared, because infrared bounces back and sends a signal, and and it shows you images. Like if I were to show you, wait, let me see if I can find something on Google. Yeah, so like over here, yeah. So actually, oh, I don't know why it went off. So these are all infrared images, okay? Infrared images also are concentrated in some areas and not concentrated in others. Usually, the more darker it is, I mean, I think this was in the book, but usually the darker it is, then the hotter it is, the higher the temperature. Infrared can actually detect high temperatures. You can use the infrared for night vision. So they can use this camera at night, even if it's fully dark, it will give you this image. Okay. Ultraviolet radiation, obviously, for tanning. Okay, this is the one from the sun, and you guys, I think all of you know, you tan from the light emitted from the sun. X-rays, obviously for medical imaging. Gamma rays, for killing cancer cells. It might not be in this chapter. I don't think it's not. I don't think it's this one. Yeah, but it was in the other chapter. I think it was last week, or I forgot, but I remember seeing it in our previous material that it is toxic and it may cause cancer. Question 6. Um, what is true about the greenhouse effect? The greenhouse effect results in increasing the temperature of the atmosphere. Obviously, greenhouse effect is يعني global warming. Okay, uh, you can say يا أخي no no لا how do no no yes no يا ربي. Okay, we're back. uh, greenhouse effect is يعني global warming. Okay, whoa, my handwriting. Wait. Global warming. Okay. What's true about global warming? Does it result in increase in the temperature of the atmosphere? Obviously. Does it? Is it because of the oxygen? Obviously not. It's because of carbon dioxide, not oxygen. CFC gas is capable of trapping infrared waves in the atmosphere. Yes. Okay. Basically, how the greenhouse effect happens, or global warming, right? GW. How it happens is basically this would be okay. I'll draw in green. So this is the soil. Okay, this is Earth. Okay, and up here is the sky. Okay, we have clouds, right? Okay, so what happens is the radiation, let's call it UV. Okay, the UV radiation, the ultraviolet radiation. Okay, it's gonna go back up into the atmosphere. Okay, usually, when what's supposed to happen is when this goes up into the atmosphere, up here into space. Let's draw yellow. Okay, up here into space. Usually, what's supposed to happen is it continues up. خلاص, it goes up, doesn't come back down. It's released back into space. But what happens now, what's been happening recently, or well, in the past 50, 60 years, is global warming. And basically, what happens in global warming is some chemicals called the greenhouse gases, which are carbon dioxide, CFCs, okay, and methane. Okay, I don't know if methane was mentioned in the book, but what these three gases do is they go to this radiation and they basically say, you know what, I'm not going to let you go to the other side. I'm gonna take you back and I'm gonna send you back down to Earth. Okay? And when they send back down these radiations to Earth, they actually increase the temperature of our Earth and atmosphere. So that's basically how it happens. So they trap these electromagnetic waves and radiations. Okay? Uh, heat trapping properties of the atmosphere are due to the absorption of radiant energy by its gases, right? It's the gases that absorb these radiant energy, okay? So this is also correct. Greenhouse effect is a recent phenomenon, obviously not, caused solely by human activity. The human activity part would be correct. However, being a recent phenomenon has always been wrong. Okay, it's been happening for the past, 100, 150 years. Uh, Question 7. Okay, what is essential for vitamin D? Obviously, that's ultraviolet. What is used to cook by stimulating water's vibrations? That's the microwave. Okay, مش إذا بتشوف cook يعني microwave, you have to read. Okay, can be used to cook by increasing the thermal energy of the substance in the food. That's infrared. Arrives to Earth as a byproduct of radioactive decay. Gamma ray. Okay, the gamma هن they come from radioactive decay. Okay, خليني أشرح الانفrared. Okay, you know how we have ovens. I think everybody watching this has an oven in their house. Okay, how do ovens cook? Ovens cook, obviously, they they increase the temperature. That's quite obvious. But how it works is electric ovens, huh? Not gas ovens. Electric ovens, what they do is they release infrared uh, waves. Okay, what infrared does is, like I showed you here, it bounces and it detects thermal energy. So you'd always associate infrared with any heat or thermal energy. And actually, this is good. Okay, it's in the book. But infrared transmits heat from the sun, the fires, and radiators. Radiators, yani air conditioners. Okay, so even heaters and stuff, they all use infrared. But if you're just using a take, you just want to increase the temperature of something, that's infrared. That's why in ovens, we don't really use them to cook unless you just want to cook a part of it, a part of your food. Okay, if يعني, how can I like, for example, baking a cake. Okay, baking a cake doesn't require actual cooking. It just requires heat, so the batter of the cake can turn into actual cake. So that's why ovens and stuff, they use infrared, and it only increases the thermal energy of the food. It doesn't cook it, it increases the heat of the food. Okay, microwaves though, they increase the whole thing, they cook it. Okay, this was in the book. Microwaves stimulate water molecules, but infrared only increase thermal energy. Okay, and by the way, if it comes in the exam, infrared has less energy than red. Okay, because it's infra. Infra means less. Yani. Okay, question 8. Go through these a bit quicker. Okay, these are the chemical conversions. All I'm gonna say is here, book. Okay, this is the whole table. Every possible one is over here. Okay, for example, a seltzer tablet convert chemical to chemical. Nuclear, okay, here no. Like a chemical, a candle would convert chemical into light energy or radiant energy. A battery would convert chemical into electrical. A stick of dynamite converts chemical into mechanical, and so on and so forth. But let's do the ones here. Okay, candle obviously converts chemical to radiant. Radiant يعني light. Okay, photocell converts solar into radiant. Sorry, radiant into electrical. Photocells هن يعني the solar panels. Okay, the solar panels, what do? They convert light energy into electric energy, and light energy, another word for it, is radiant. Electric heater converts electric into thermal, obviously. Steam turbine converts electric into thermal to mechanical. Okay, what a steam turbine is, it's like a fan. Okay, and it turns when steam pushes on it. Okay, steam is like boiled water, right? Boiled water, or you could say water vapor, right? And since it's a really hot gas, boiled water is hot. It's very hot, and it's always expanding because gases are very big. Like the size between the atoms is very large. So it keeps on spinning this. It keeps on spinning this these turbines. So basically, the thermal energy of those steam molecules will spin that turbine and cause it to spin. So the thermal energy to mechanical energy. And a stick of dynamite is chemical to mechanical. Okay, and the photographic film would be radiant to chemical. Photographic film is basically the camera. Camera, what does it do? It captures light energy and it prints it. Obviously, it's printed as a chemical. You know how those are actually chemicals that you see on the paper when it's printed, or even when you see the picture, those are chemicals. ف يعني you memorize them. Question 9, a lamp is connected to a battery and it's turned on. Okay, what happens? Okay, so obviously it starts from the battery. What happens in the battery? The chemical energy in the battery is converted into electrical energy. Okay, then we go to the lamp. Okay, the lamp converts this electricity into light energy or radiant energy. Okay, بسيطة. Question 10. Okay, هول where's yeah. So hydroelectric, what's it called? Uh, on, I think stage 8. Yeah, a hydroelectric power station. So hydroelectric power stations basically, and you guys can read over this. Okay, uh, basically what happens? There's water. Okay, potential energy of the water in a high level tank or reservoir. It falls. The water falls, and then it spins a turbine. And that turbine, when it spins, the rotation of it is turned into electrical energy. Okay, and then there are some energy that's wasted. Okay, no, that's normal. Uh, alhamdulillah, alhamdulillah. Yeah, chill, man. Oh, he's still going. Yeah, sorry. How it works, you'd have like a really high platform, okay, where there's water. Okay, there's water here. Okay, then the water, since it's falling, it's gonna fall down really quickly and really strongly. Okay, since it's falling really strongly, it spins this turbine over here. This turbine spins, giving me electric energy. Okay, sometimes there's extra energy produced. That's what we call surplus energy. Okay, it's available late at night. Okay, and it's used to pump water into a reservoir. So this extra electric energy is used to pump water into a reservoir. A reservoir is يعني uh, what's it called? A reservoir يعني a storage place for the water. And then at peak times where it needs electricity the most, the stored water runs a hydroelectric turbine generator to provide extra electric energy. What happens is there's extra energy produced here. Okay, let's draw it again. Water. Okay, at night time. Okay, when we don't really need electricity. Okay, this is still flowing. It's still spinning my turbine. Okay, for what it does with this extra electric energy that is produced at night, it takes this water back and pumps it back up to the top. Okay, so the next day, in the daytime, when it really needs the energy, it pumps it down faster and produces more electric energy. Okay, Question 11. Okay, actually, no, I didn't even do the question. Okay, so surplus energy available at night is used to pump water into a reservoir, and then at peak times, the stored water runs a hydroelectric turbine generator. And then again, what happens in this generator? It converts the energy of the falling water into electric energy. Question 11. Okay, what what are some effects of fossil fuels? Akid acid rain, carbon dioxide release, and the greenhouse effect. Is it oxygen intoxication? No. Is it greater light energy? No. Question 12. Uh, what way are nuclear power plants reliable? Okay, they respond quickly to any fluctuation in electricity demand. So if you need more electricity, we just burn more uranium in the nuclear plant. Question 13. Okay, changing the battery of a car. Sorry, charging the battery of the car. Obviously, when we charge it, it's going from electric into the battery, which is chemical, right? And then burning a candle, it's chemical into radiant. Okay, so we're burning the chemical into radiant or light energy. Turning on a light bulb, we only want the light bulb. Okay, the light bulb, what it does, it converts the electric into radiant, right? Okay, and then applying the brakes. Into when you're driving a car or bike or any scooter, I don't know, uh, when you brake, okay, you would be moving, right? So it would convert your mechanical energy, which is your moving energy, your kinetic energy, into brakes. And those brakes actually create friction, which causes a lot of heat, thermal energy. If you go, uh, if you've anybody has seen cars that drift, if you touch the wheels of any car that has been drifting, you would burn your finger because it would be very hot. Why? Because when they drift, they apply brakes, and the brakes actually cause a lot of thermal energy to pile up, and that's why it would make the wheels really hot. And sometimes actually you would burn the rubber on the wheels. Question 14. Mashbi. Okay, خلاص, that's it. Thank you so much for watching. Good luck.